Okay, hey there folks. I'm going to walk you through a couple of these case study examples, and actually this video will take you through all the case study answers if you want, but what I'm going to recommend is that you follow along through the warm-up, then try the rest of the case studies on your own, checking the key, and come back to this video if you need some more explanation. Okay? All right, so here's what you're going to need. You're going to need your reference tables. You're going to need your timeline helper sheet. You're going to need that Algor Mortis flowchart, and then you're going to need the case study worksheet. Either you're looking at a printed out PDF or you've got the electronic editable copy. Okay, and it looks something like that. It says time of death case studies at the top. Okay. All right, so let's try these two warm-ups. Okay, warm-up A, a corpse has permanent lividity and full body rigor. Determine the time that has passed based on both pieces of data. Okay, first let's try the lividity or the liver mortis. Permanent lividity is easy. It means it's been more than 8 hours. Okay, that comes right off of your timeline. And then as far as the rigor information, okay, it's got full body rigor. Rigor is complete in the entire body. That only happens at the 12-hour mark. And from about 12 to 15 hours, you've got full body rigor. After that, it starts to fade. So based on the two pieces of evidence, we can say, okay, it's been over 8 hours. It's 12 to 15 hours. Those are in agreement. So the best estimate of the time of death is 12 to 15 hours ago. 12 to 15 hours has passed. Okay, warm-up B. A little more complicated. Going to have to use some math. Okay, a corpse has rigor only in the legs and chest, not arms or face. Body temperature is 22.6 degrees. Use both pieces of data to determine the time since death. All right, with the rigor, I would say between 15 to 36 hours. The rigor has faded in the face and arms, but is still present in the chest and legs. So it's about half faded. Halfway between 15 and 36 is about 25. Okay, so we're going to try to make an estimate something closer than just that giant range of 15 to 36. Sometimes that's a little tricky, but in this case, I called it half. All right, the Algor mortis, the cooling of the body. Okay, we need this flowchart, and what do we do first? We'd say, okay, 37 degrees minus 22.6 degrees, because the corpse is now at 22.6, gives us a drop of 14.4 degrees. All right, 14.4 is bigger than 9.36. Okay, so on this part of the flowchart, if it's greater than 9.36, we don't get to follow that. We have to follow this part of the flowchart. Okay, so it dropped 9.36 degrees in the first 12 hours, and we have to figure out what is the drop after 12 hours. So 14.4 degree total drop. Take away 9.36 degrees that happened in the first 12 hours. That gives us 5.04 degree drop after 12 hours. Now we take that 5.04 divided by 0.39. Okay, and we'll write down here. That means after 12 hours, 12.9 more hours passed. Okay, 12 hours was the time for the temperature to go down 9.36 degrees. 12.9 more hours was how long it took to go down the additional 5.04 degrees. So we take 12 hours plus 12.9 hours, we get 24.9 hours. Remember, when you are in this part of the flowchart, your final calculation is always going to be 12 plus something. Okay, 12 hours for the first 9.36, some other number that you calculate for the chunk after that. And so these match pretty well. We could say our time of death was about 25 hours ago. That usually doesn't work out this nicely, but our guess of halfway between 15 and 36 worked out okay. All right, so, all right, next up, case 2. I just want to point something out before you try this on your own. Okay, we found this naked male corpse, okay, but it's in an environment that is very hot, hotter than normal, 81 degrees Fahrenheit. That's a really hot summer day. So the hot surroundings are going to mean that you're going to make some estimates, but you're going to have to change them based on the very hot surroundings. Okay, so you're going to definitely need your flowchart as well as your timeline for rigor mortis, because we've got some rigor mortis information. So hit pause, try this case number 2 on your own. Okay, so here's how I would calculate this. First, I'm going to realize I've got a few different pieces of information, so my answer for A is going to be a combination of evidence that I hopefully will agree. Okay, so based on the body temperature evidence, okay, we tried the Algor mortis method. 37 degrees is what we start with, and the corpse was at 34.6. That's only a 2.4 degree drop. Great. So it's been less than 12 hours according to the Algor mortis. So we just take 2.4 degrees, divide by 0.78, okay, following this part of the flowchart, and that tells us that it's been about 3.1 hours, okay, 3.1 hours, but let me just erase this, okay, we have to take into account the hot surroundings, the hot temperature surroundings. Now, heat slows cooling. You should have that written on your timeline, okay? It's really hot. The body is not going to cool down as quickly. Heat will slow the cooling, so it will take longer to cool down. Since our estimate is small, okay, 0 to 10 hours, we have to add or subtract 3 hours. In this case, we're adding 3 hours. So our estimate based on Algor mortis would be 3.1 hours plus 3 hours, about 6 hours. Okay? So now we're on to rigor mortis. All right. With rigor mortis, I would say between 12 and 15 hours. Okay? The body has stiffness in the face, chest, and legs. It has not faded anywhere. Basically, it's got rigor completely throughout the body, and it hasn't started to fade. So somewhere between 12 and 15 hours. But now, okay, it's a very hot environment. That speeds up the rigor mortis process. Okay, so we're going to have to subtract from that. What do we subtract? Well, this estimate of 12 to 15 hours is, not too small a number. So we are going to have to subtract about 7 hours. That means instead of 12 to 15 hours, it's a range of about 5 to 8 hours. Okay? Now, those actually agree pretty well. Algor mortis told us about 6 hours. Rigor mortis said between 5 and 8 hours. So the most accurate we could say is about 6 hours ago. Okay? Now, question C is actually kind of a poor question, but we'll give it a try anyway. The Algor mortis calculation. Insulation, okay, if the person was found wearing a heavy jacket, that insulation would have slowed the cooling process. The cooling would have taken a longer time. So we would add more time. Add about 3 hours, we'd get something like, okay, I guess our estimate would have been 9 hours. This is where it gets weird. Based on the current temperature, insulation speeds the rigor process. Okay, when things are warm, the rigor process happens faster. That means it happens in a shorter time. That means instead of 5 to 8 hours, instead of 5 to 8 hours, we subtract 3 hours. That becomes 2 to 5 hours. But the goofy thing here is that, well, these are no longer in agreement. Honestly, with a question like that, once you start saying, oh, well, what if it was wearing a jacket, or what if it was doing this, or what if it's doing this, we don't have the actual data. So this is just kind of a poor question. But insulation slows the cooling process, and insulation speeds up the rigor process. Those are both true things. The data here just is not enough for us to do anything useful. Okay, so don't worry about question 2C. Okay, case 3. We've got a female corpse found mostly submerged near the shore of a small lake. The water temperature is 15.6 degrees. That's pretty cool. So we're in very cold surroundings. That means we're going to make some estimates. Then we're going to have to adjust them based on being in cold surroundings. Air temperature is 21 degrees. That's about room temperature. So that's not too hot, not too cold. We've got some information about rigor mortis. We've got a body temperature that is pretty cool. It's cooled down to the temperature of the lake. We've got some information about liver mortis. Lungs were full of water, bacterial activity not significantly increased. We don't really know much about that. That's for a pathologist to determine. So we're going to come up with an answer for how long ago this woman died based on several pieces of information that we'll try to see if they're in agreement. Okay, first up, the Algor mortis calculations. Okay, we've got a temperature of 15.6 degrees of the corpse. That means it dropped by 21.4 degrees. 37 minus 15.6, 21.4 degree drop. That's larger than 9.36. So we're not following this part of the flowchart. We're following this part. That means in the first 12 hours, it went down by 9.36 degrees. What's the second drop? 21.4 minus 9.36. After 12 hours, it went down 12.04 degrees. 9.36 plus 12.04 adds up to the total drop. Anyway, now we take that 12.04, which is the drop after 12 hours, divide by 0.39. Okay, we're right here. We come up with 31 hours after the first 12 hours. So our estimate is 12 hours plus 31 hours gives us 43-hour total. But now we have to modify it based on the cold surroundings. Cold speeds cooling. Cooling will happen in a shorter amount of time, happens faster. So 43 hours, take away 10, gives us 33 hours. How did I know to take away 10? Remember, I gave you some plus or minus estimate numbers that I recommend you using. And if your estimate is a number bigger than 25, I think I said, then you add or subtract about 10 hours. Okay, so our Algor estimate is 33 hours. Now let's do our rigor mortis. What do we know? We know we've got rigor mortis in the entire body except the face, so it's just started to fade. It's over 15 hours by a couple hours. Okay? It's only started to fade in the face, so 15 to 20 hours is pretty good. But then it's in a cold surroundings. Cold slows rigor. It makes rigor happen more slowly. It takes more time. This number, 15 to 20 hours, means that we add about 7 hours. So 15 to 20 becomes 22 to 27 hours. So our rigor estimate is 22 to 27 hours. Okay? Now, liver mortis. Liver mortis present, did not disappear when pressed. That means the liver mortis or lividity is permanent. Okay? So lividity tells us that it's been over 8 hours. But cold slows lividity. It makes it happen more slowly. It takes longer. So we add 3 hours to our estimate. So our lividity data tells us, okay, it's been over 11 hours. So what do we got? Algor mortis tells us 33 hours. Rigor mortis tells us 22 to 27 hours. Liver mortis says over 11 hours. Okay, right off the bat, the liver mortis is in agreement with both the other numbers. Algor and rigor, not quite exactly aligned. So our best estimate based on this would be, Algor says 33, rigor says 22 to 27. Let's call it somewhere between 27 and 33 hours ago. That's the best almost agreement we can get between these three pieces of data. Again, it agrees with liver, and it's kind of in between our Algor and our rigor information. So that's the best you can do with this. All right. In your reference tables, you've got this tiny little chart, and I suggested that you add a little bit of information from 0 to 2 hours, food just barely starts to be digested, and then you've got some information about where it goes in the body. Remember, your digestive system stops when you die, so what does the stomach tell you? It tells you how long before death the victim ate their last meal. It doesn't tell you time of death, but how long ago they ate their last meal. Okay. Body is found with food in the stomach that appears to be undigested. We're doing 4A. Noodle fragments are visible, small pieces of leafy green material. How much time has passed between the last meal and the time of death? I would say less than 2 hours. If it's really, really undigested, you could say less than 1 hour. Okay. In this case, They say it appears to be undigested. So maybe we'd say less than 1 hour. A body is found with no food in the stomach, but food in the small intestine. How much time passed between the last meal and the time of death? Okay, it's been over 6 hours because food has left the stomach. Okay. It's been less than 12 hours because food is still in the small intestine and it hasn't left the small intestine yet. So we could say, oh, it was 6 to 12 hours since their last meal and the time of death, or between the last meal and the time of death. The body has no food in the small intestine, but food in the large intestine. How much time passed between the last meal and the time of death? It's been over 12 hours because the food has left the small intestine. It's been less than 24 because food is still in the large intestine. So we would say 12 to 24 hours since the last meal before the time of death. All right, let's try 5, bloating and decomposition. And this information comes straight from the stages of decay for predicting time of death. This is a little chart in your reference table. We're just going to look at the top half of it. Body is found with slight swelling in the abdomen, and the skin is heavily discolored. Is the body 1 day old, 3 days old, or 8 days old? What do we got? Okay, based on the color discoloration, the skin is very discolored. Well, it's probably at least 2 days old because discoloration of the skin starts 0 to 2, and then discoloration is going to really be extreme after 2 days. The swelling tells us somewhere close to 4 days. The abdomen is slightly swollen, but it's not hugely bloated. So it's been at least 2 days, approximately 4 days. The agreement for that would be about 3 days old. And we only have 3 choices. So we're going to say, okay, definitely more than 1 day, but not as much as 8 days. 3 days is the best estimate. 5b, the body is found that has no bloating, but the skin has a greenish tint, a little bit of discoloration. Is it 1 day old, 3 days old, or 8 days old? I would say the discoloration tells us it's in the 0 to 2 day range. Okay, there's no swelling or bloating, so it's definitely less than 4 days. I would say that's closest to 1 day out of those 3 choices. Okay, it's in the 0 to 2 day range. It's less than 4 days. 1 day is a good estimate. 5c, the body is found that has severe bloating and the skin is extremely blistered and peeling off. Is it 1 day old, 3 days old, or 8 days old? Well, severe bloating means 6 to 10 days. Okay, the blistering means it must be at least 4 days, something past 4 days. So 8 days old would be a good estimate out of those 3 choices. Okay, and again, if you have to use this chart, the data you'll get will be pretty closely matching this. They're not going to ask you to make wild guesses with this. Okay, thank you for watching these case studies. And if you can make it through these case studies, you will be in good shape for the required assignment quiz. Okay.